Hi everyone. So today we're going to be talking about trig functions of angles. So in the last lesson that we did, we talked about trig functions in the context of just right triangles and solving for missing side lengths. But in this case, we're actually going to be taking trig functions of angles, which is a lot like what we did in Unit 5 with the unit circle. Okay, so let's start with sine, cosine, tangent. So sine of theta, right, is one of our trig functions. We have cosine of theta and tangent of theta. These are all familiar. We're just going to kind of look at them in a slightly different context. We're also going to be looking at their reciprocals. So the reciprocal of sine is cosecant. We always take a trig function of an angle. Reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Okay, so what we're going to be doing is drawing what we call reference triangles. Now, this one that I'm drawing is specifically in quadrant 1, but they're not all necessarily going to be in quadrant 1. So we have an angle. Whoops, let me redraw that a little nicer. Okay, does not want to do a straight line through those 2 points for some reason. Okay. Let me just try to make it as straight as I can. Okay. So we have a reference triangle. I'm going to drop it perpendicular down to the x-axis, just like this. And I have a right triangle with this angle theta. Okay, so the distance, if this is the point x comma y, the distance, the horizontal distance would be x, and we'll go ahead and color code this. The vertical distance would be y. And then let's just call the hypotenuse, I guess you can say, or even it's a radius in this case, because you can think of the fact that that terminal side would rotate, right? We'll call it r. So in this context, we can come up with different trig ratios. So in this context, sine of theta, it's still opposite over hypotenuse, but our opposite leg is y. So we have y over our hypotenuse, which in this case is r. And then we just take the reciprocal of that for cosecant. So not much different from what we're doing. We're just defining that horizontal leg as x, the vertical leg as y, and the hypotenuse as r. Cosine is adjacent over hypotenuse. So the adjacent leg is x over our hypotenuse, which is r. And then secant is just the reciprocal. So it would be r over x. Okay, tangent of theta is opposite over adjacent. So this would be y over x. And then cotangent, we just flip it. We take the reciprocal. We get x over y. Okay, so we're going to use this concept to evaluate trig functions at different angles. All right, so in the last unit, we used key points from the unit circle to help us evaluate trig functions. It was primarily memorizing all the different coordinate points at all of those key angles, right? But in this unit, we're actually going to shift from memorizing to actually using some other skills to evaluate trig functions at any angle. We can create a reference triangle by connecting a point on the unit circle to the circle's center and dropping a perpendicular line to the x-axis from the point on the circle. All right, that was a lot of words. Let me show you in a picture. So let's say we have our terminal side here. We always start on the positive x-axis, and we have some angle that's rotated maybe into quadrant 3. And so we have our terminal side right here. Well, this angle it's not an acute angle, right? It's larger even than 180 degrees. So what you can do is you can take this point where the terminal leg or terminal side of your angle intersects the circle, and you can drop a perpendicular line to the x-axis. And what that forms is a little right triangle with this reference angle theta. And the way that we write a reference angle is theta with a little line over it. It looks like a little hat. Okay, all reference triangles on the unit circle are right triangles with a hypotenuse length of 1. So the hypotenuse length right here for this reference triangle is 1, which is really going to help us out when it comes to evaluating these trig functions. Okay, so let's start with just the reference angle piece, and then we'll throw it all together with actually evaluating the trig functions. So let's start with number 1. We have theta equals 5 pi over 3. So what we're going to do is we always start on the positive x-axis. That's our initial side. Remember, this is 0 or 2 pi. Up here we have pi over 2. Then we have pi. Then we have 3 pi over 2. We're going to rotate counterclockwise since this is a positive angle, and this is 5 pi over 3. So think of this right here. This is 3 pi over 3. This right here would be, let's see, well, if we compare it, we'd actually want a common denominator of 6. So like 10 pi over 6 versus 9 pi over 6, right? So it looks like we're actually going to land in quadrant quadrant 4. So we're rotating until we get to quadrant 4. Okay. And so it looks like we're about right here with our terminal side. So we can go ahead and draw that in. And then now what we can do is where the terminal side intersects the circle, we can drop a perpendicular line. And notice we now have this little reference triangle and our little reference angle, theta with a little hat. Well, we want to actually calculate what the value of that theta reference angle is. Well, okay, to go all the way around the unit circle would be 2 pi, right? But we went 5 pi over 3, and I want to know what's left, right, to get to 2 pi. So what I can do to calculate that reference angle is I can take 2 pi and I can subtract off 5 pi over 3. Okay, so then we need a common denominator. I'm going to multiply 2 pi by 3 over 3, which is 6 pi over 3 minus 5 pi over 3. So our reference angle is pi over 3. Okay. All right, let's go ahead and take a look at 870 degrees. So now we're in degree mode. We have 0 degrees, 360 here. We have 90 degrees, we have 180, and we have 270. We always start on the positive x-axis. And in this case, we're going to rotate counterclockwise once again. Now be careful here because 870 degrees, we're going beyond 360. And we want to know how much beyond 360 degrees, right? So it looks like 360 times 2, right, is 720. If I do those 2 rotations, I just did 720 degrees. But to get to 870, I still need to do another 150, which is a little less than 180. So it looks like we're going to be right here. And so we land in quadrant 2. And once again, we plot the point where our terminal leg intersects the circle. We drop a perpendicular and we get our little reference triangle with our little reference angle right here. Okay, well, we know just based on the math that we did that this distance I just traveled was 150 degrees. So we went 720, we had to go another 150 to get to 870. So to get that reference angle, we don't want to go all the way to half a circle, 180, right? So we have 150, and then what was that extra bit to get that full 180. So we can just take 180 degrees, subtract off 150, and we should get our reference angle, which in this case is 30 degrees. Notice the reference angle is always an acute angle. It should always be less than 90 degrees or pi over 2 radians, because these are right triangles. And if you don't have acute angles, then you really don't have a triangle. So be careful with that. All right, let's go ahead and move on. So putting this all together, we are going to actually be able to evaluate any trig function at any of these angles by finding a reference angle. Okay, so it says now we'll use our knowledge of trig and reference triangles to evaluate trig functions. Step 1, draw a reference triangle and label the value of the reference angle. That's your theta with the little hat, right? Okay, then it says determine the sign, that's positive or negative, of the trig function based on the quadrant theta lands in. So your actual original angle, where does theta land? Evaluate the trig function at the reference angle. The value of the trig function at theta will be the same, except you may have to change the sign. Okay. Let's take a look at number 1. So let's start theta equals 240 degrees. So what we're going to do is we're going to start at our initial side. We're going to rotate 240 degrees. So remember, this is 0, 360. This up here is 90. We have 180. And we have 270. So 240 degrees is going to land somewhere in here. And so we rotated that, right? We can drop our perpendicular. We end up with our little reference triangle. And this right here is theta with a little hat. Okay, let's figure out what theta with the little hat is. Okay, so it looks like we went 240. If I subtract off that 180 at the top, right, I'm left with my reference angle. So theta is 240 degrees minus 180 degrees, okay? So we end up with theta. Okay, so we end up with theta equals, let's see, 240 minus 180, okay. We get 60 degrees. Okay, so our reference angle is 60 degrees here. So what we want to do is we actually want to find sine of 60 degrees. And then what we can do is change the sign. So based on what quadrant it's in, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, where our angle theta is in quadrant 4. Well, thinking about all students take calculus, the only one positive in quadrant 3 is tangent. So that means your answer should be negative. So you can preemptively put a negative sign there. Now, sine of 60 degrees, if you have the unit circle memorized, 60 degrees is that triangle that's a little taller up here, right? So it should be root 3 over 2. But let me show you a little trick in case you've forgotten. So remember, this we just said is 60 degrees, so this would be 30 degrees. Remember, the hypotenuse on a unit circle is always 1. Okay? This is a 30, 60, 90 right triangle. Now, the side opposite of 30 degrees is the shortest leg. It's half of the hypotenuse, right? So this would be a half. You multiply the short leg by root 3 to get the long leg, which is root 3 over 2. So there's a little trick. And remember, sine is always opposite, root 3 over 2, over hypotenuse, which is just 1. So you get negative root 3 over 2. Those are two different ways to evaluate this problem. Okay, let's do another one. Let's do one that is in radians. Let's take a look at number 3. So I have 16 pi over 3, and we're finding sine. We always start at our initial side, which is the positive x-axis. We're in radians, so I'm going to go ahead and label these in radians. Okay, so what we're going to do next is we are going to rotate counterclockwise since we have a positive angle. Now this is 16 pi over 3. So if we did, let's see, 2 pi would be, 4 pi or 6 pi over 3. How many 6 pi over 3s can we fit in there? Let's see. So it looks like 2. So we can go 2 full rotations, right? If we deduct that 12 pi over 3 that we just did, we have a 4 pi over 3 left. So 4 pi over 3, let's see where that lands. It's a little beyond pi, right? 4 pi over, that would be 3 pi over 3. So we have 4 pi over 3, which would land about right here. So it looks like we're landing in quadrant 3 again. And so our sine answer should be negative because we're in quadrant 3. So I like to throw that negative on there just preemptively because I know my answer should be negative. We make our little reference triangle, and then we have our reference angle theta with our little hat. Okay, so let's find our reference angle theta. Okay, well, actually, we went 4 pi over 3 after we did the 2 full circles, right? So this whole distance was 4 pi over 3. If I get rid of pi, I should be left with my reference angle. So 4 pi over 3 minus pi, which is 3 pi over 3. My reference angle is pi over 3. If you remember, that's actually 60 degrees, right? These are equivalent. So once again, we have a 60 and then 30 here. Remember, your hypotenuse is 1 for these. The shorter leg would be a half, and the longer leg would be root 3 over 2. And so sine is opposite over hypotenuse, so this answer is also negative root 3 over 2, just like we got in the last one. All right, let's do one more together. Let's do one that's a little different. Let's take a look at number 8, tangent of 570 degrees. Okay, so we're back in degrees. We're going to start with our initial side. And so we are rotating once again counterclockwise because we have 570 degrees and it's positive. Now remember, we are going to do more than one rotation, it looks like, because yeah, 360. It's not going to be quite enough. So we have 90 up here, 180, 270. Okay, so after I do the first 360 degrees, how much further do I have to go? It looks like 210, right? So 210, it looks like we're landing in quadrant 3 again. 210 is right here. So let's see. We're going to put our reference triangle in with our little reference angle theta. Let's go ahead and find that reference angle. So we did our full 360, and then after we did the 360, we still had an extra 210 to go. If I deduct off this 180, I should be left with my reference angle. All right, so 210 minus 180 is 30 degrees. So we have a 30, 60, 90 triangle. Be careful here. Although this one is also in quadrant 3, your reference angle is 30 degrees, not 60 degrees. So the side opposite of 30 degrees, remember, is a half. It's over here. And then on this side is root 3 over 2. Now we're in quadrant 3, so tangent should be positive. Remember, tangent is opposite, which in this case is 1/2, over adjacent, which in this case is root 3 over 2. We can multiply by the reciprocal. 2 over root 3. We end up with 1 over root 3, which if we rationalize, we get root 3 over 3. So tangent of 570 degrees is equal to root 3 over 3. Okay, so go ahead and take a moment, pause this video, go ahead and do 2, 4, 5, 6, and 7. Once you've done them, go ahead and unpause, and I will go over them with you. All right, so let's take a look at number 2. We have cotangent of 495 degrees. So we're going to go ahead and start once again at our initial side. I like to go ahead and label these because it's easier for my brain to compute how far I need to go. So we have 495 degrees. Well, if I do one 360-degree rotation, then I'm left still with an additional, it looks like 135 degrees to go. So I need to go a little bit past 90 degrees. And then we can go ahead and draw in our little reference triangle. Okay, so this one, we will put our reference angle right here. We need to figure out what our reference angle is. We will find cotangent in just a moment, but we're not quite there yet. So remember, we did a 360-degree rotation, right? So when we did that 360-degree rotation, right? Let's see, we have 5, we had 135 degrees left, right? So what we want to do to find the reference angle is we take 180 degrees and we subtract off the 135. And so what we end up with is a reference angle of 45 degrees. So this is a 45, 45, 90 triangle. The hypotenuse of a 45, 45, 90 for a unit circle is going to be 1. But remember, we multiply the leg by root 2 to get the hypotenuse. So to undo that, we're going to divide by root 2 to get the legs. 1 divided by root 2, when I rationalize, I get root 2 over 2. Eventually, you won't have to do a lot of math to get this. You'll know what these triangles will look like. Okay, cotangent. All students, the only one positive in quadrant 2 is sine. Tangent and cotangent are negative, so you should get a negative answer. And remember, it's adjacent over opposite because it's the reciprocal. So it'd be root 2 over 2 divided by root 2 over 2. Anything divided by itself is 1. So cotangent of 495 degrees is just negative 1. Okay. So what we're going to do is next we're going to let's do number 4. Yeah, let's keep going through these because I think seeing more of these is good. All right, number 4, we're taking secant of negative pi over 4. We're going to start on the initial side once again. This is in radians, so we have 0, 2 pi, pi over 2, pi, 3 pi over 2. We are now going to actually rotate clockwise, and we're going to go just pi over 4, so just like this. And we can drop our reference triangle. And remember, theta, or reference angle, it's actually just pi over 4 because that's the distance we just traveled. So theta, reference angle theta, is pi over 4, which if you remember is 45 degrees. So this is a 45, 45, 90. Hypotenuse is 1, and those legs you end up with root 2 over 2. All right, secant. It's the reciprocal of cosine. So instead of adjacent over hypotenuse, it's going to be hypotenuse over adjacent. Now, all students take calculus. It looks like it's going to be positive because cosine and secant are positive. So hypotenuse 1 over adjacent, which is root 2 over 2, we can multiply by the reciprocal. Okay, we get 2 over root 2, which we can rationalize. And it just equals, let's see, 2 root 2 over 2, which is just root 2. So secant of negative pi over 4 equals root 2. All right, so see how you do not need to memorize the unit circle to evaluate these trig functions. Okay, number 5, we have tangent of 5 pi over 2. So once again, we start on our initial side. And we have 0 to pi over 2 up at the top, pi, then 3 pi over 2 down at the bottom. Okay, 5 pi over 2. Well, this one is a little bit tricky. So we go 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. We are actually coterminal to pi over 2 right here. Now, this one is hard because you actually can't make a reference triangle, because if you drop a perpendicular, it's just a line, right? But remember, the distance of that is always 1. So this is at the point 0, 1. And remember, tangent is always actually going all the way back to what we did up here. Tangent of theta is y divided by x, okay? So looking at that coordinate point, y is 1 divided by 0. Can we do 1 divided by 0? Ooh, no, this is actually undefined. Okay, so we cannot evaluate tangent at 5 pi over 2. Okay, let's go ahead and look at number 6. So we have cosecant of 5 pi over 4. So once again, we draw our initial side. We're going to go 0 to pi. This is pi over 2. This is pi. This is 3 pi over 2. All right, 5 pi over 4, it's a little bigger than 4 pi over 4. So we're landing in quadrant 3, it looks like. Again, lots of these were in quadrant 3. Okay, so we drop our perpendicular. We get our little reference triangle with our little reference angle. And this reference angle would be theta with our little hat. It would be 5 pi over 4, but we want to subtract away pi, which is 4 pi over 4. So our reference angle is pi over 4, which if you remember, is 45 degrees. So we have a 45, 45, 90. Hypotenuse is 1, legs are root 2 over 2. Cosecant, it's the reciprocal of sine. So instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. Now be careful, all students take, the only one positive in quadrant 3 is tangent, not cosecant, so it's going to be negative. Hypotenuse is 1 over root 2 over 2. And you may remember this from the last one we just did. This will simplify to negative root 2. Okay, last one on this page. We have cosine of negative 60 degrees. So remember, we start on our initial side. We have 0, 360, 90 up at the top, 180, and 270. We're going clockwise this time, but only 60 degrees. So we land right about here. We can go ahead and draw in our little reference triangle. And actually, our reference angle is just 60. So this is 60, this would be 30. Hypotenuse is 1. Smaller leg is a half. Larger leg is root 3 over 2. And so remember, all students take calculus. Cosine's positive. You don't need to make your answer negative. Cosine is adjacent, which is a half, over hypotenuse, which is just 1. So we get a half for this one. All right, let's go ahead and work through some problems where I give you one of the trig functions and what quadrant it's in, and then you need to find the remaining trig functions. So let me show you how to do these. So number 1 says if tangent of theta equals 2/3 and theta is in quadrant 3, find all 6 trig functions of theta. So here's what I like to do. I like to draw a picture of my axes, and theta is in quadrant 3. So if I were to rotate, I'd end up with a little reference triangle that looks something like this in quadrant 3. All right, so we have theta with a little hat, right? And tangent of theta is 2/3. Remember, tangent is opposite over adjacent. So the opposite leg is 2, the adjacent leg is 3. And so we can use that to go ahead and solve for the hypotenuse. So 2 squared plus 3 squared equals c squared. 2 squared is 4, plus 3 squared is 9 equals c squared. 13 equals c squared. Square root, we get c equals plus or minus root 3. Okay, so we're going to find all 6 trig functions at root 13. And I'm going to put root 13 on my triangle too. All right, so this is what I like to do. Remember, it's in quadrant 3, so that determines the sign of your trig functions. So we have cosine of theta we need to find. Sine of theta we need to find. Tangent of theta we're given is 2/3, but we also need to find their reciprocals. So secant of theta, cosecant of theta, and cotangent of theta. Well, cotangent's easy because we're just going to flip, so it's 3/2. Okay, but we need to do some work to find cosine, sine, secant, and cosecant. Now, all students take calculus, which means the only trig functions that should be positive are tangent and cotangent. Go ahead and just throw some negatives right in front of your answer before we even get there. Okay, so cosine. Cosine is adjacent, which is 3, over hypotenuse, which is root 13. Now, if we rationalize this, we should get negative 3 root 13 over 13. If you flip it, you should get negative root 13 over 3 for secant. Sine of theta is opposite, which in this case is 2 over root 13. If you rationalize it, you get negative 2 root 13 over 13. If you flip it, you get negative root 13 over 2 for cosecant. So that's the gist of it. Just be careful of what quadrant you're in so you remember to change the signs. Okay, let's do one more together, and then the other 2 I'm going to have you do on your own, and then you'll check your work on my website. So number 2, if cosine of theta equals negative 1/4, I'm actually already going to write that out over here. So cosine of theta equals negative 1/4. Remember, the reciprocal of cosine is secant. We can actually just flip that and do it now. So it's negative 4. We also will have to find sine of theta, which means we need to find cosecant of theta, tangent of theta, and also cotangent of theta. All right, let's draw our picture. So I'm going to draw my axes. We will start on our initial side. Remember, if we rotate, we're rotating into quadrant 2. So you'll get a reference triangle that looks something like this. All right, we have our reference angle right here. Cosine, it's 1/4 adjacent, 1 over hypotenuse, 4. And then we can use Pythagorean theorem to find that third side. So 1 squared plus b squared equals 4 squared. 1 plus b squared equals 16. Subtract 1, and b squared equals 15. Square root both sides, and b equals plus or minus root 15. Okay, now let's find our trig ratios. Now be careful, all students, the only 2 trig functions that should be positive in quadrant 2 are sine and cosecant. Tangent, cotangent, cosine, and secant should be negative. Add those negatives now before you forget. All right, sine of theta. Sine is opposite, which is root 15, over hypotenuse, which is 4. Take the reciprocal, we have 4 over root 15. I would rationalize that. We get 4 root 15 over 15. Tangent is opposite over adjacent, which would be negative root 15 over 1, which is just negative root 15. Cotangent would be negative 1 over root 15. And if you were to rationalize that, you get negative root 15 over 15. Okay, so that's as much as we are going to be doing together. Go ahead and do numbers 3 and 4 on your own, and you are going to check your work on my website, mrsfitzmath.com. Thank you for watching. That's all for today.